heating effect of current, you can do an activity also. This is a simple activity I can show you over here. We have a circuit, we have a cell, we have a small bulb, we have a switch. In this, switch on the circuit for a while and then see the difference of the temperature of the surface of the bulb. You can say this activity over here. We have a circuit, it is switch off, the temperature is low, switch on for a while and then touch the bulb. You can see the difference in the temperature. Previously, when it was switched off, when the bulb was not glowing, the bulb was at a normal temperature. But after you switch it for a while, take half a minute and then don't go for too long. You can burn your hand also, so you can be precautious over here. So just for a while switch on and then see the surface of the bulb. You can see that it is warm. So what does this shows? That this electric current produces a heating effect. Okay, more examples are there. There are certain more examples. You can see the bulb. Inside the bulb there is a coil type thing, filament. We call it filament. It is made of tungsten. So this filament gets heated up due to the current. The wire gets heated up. Not all wires get heated up. We'll talk about that also. Let's do one more activity to see the heating effect of current. Here you can see a circuit diagram, and don't say that you don't know what is it. We have discussed about circuit diagram before, that this is a switch, this is the source cell. Okay, now two screws over here and I have another wire. These are connecting wires made of copper or aluminium, but I have one more wire on the top. You can see that wire, it is an alloy wire. I can have nichrome, I can have tungsten over there, and then you switch on the circuit for a while. Just switch on the circuit for a while and then you can see when you switch it on, this wire gets heated. This wire, not the whole circuit, this particular wire, because there are certain wires, certain elements, certain alloys are used to make wire which gets heated up due to current. Okay, so this is also there in higher classes. You will study which wire gets heated up, which wire doesn't get heated up. Remember, this connecting wires, copper or aluminium, they don't get heated up. They get heated up but very minutely. Okay, so you don't feel that sense over there. So this wire gets heated up. So you can feel that nichrome wire, you can feel the temperature of the wire before the circuit and after the circuit, so that we can say that okay, when the current was passing through the conductor, from this conductor, it gets heated up. This effect is called heating effect of current. When a current passing through a conductor heats up the conductor, anything through which a current passes and then heats it up, this phenomena is called as heating effect of current. Okay, so there are many devices which works on heating effect of current at your home also. You can see, can you name some appliances? Can you recall some appliances at your home which use heating effects? You can say electric geyser, is it? Toaster, electric oven, the OTG I can say. I don't say about microwave, I can say about OTG. Oven is there. Any more? Electric iron. Okay, so we all have electric iron, electric geyser, electric kettle at our homes which work on the heating effects of electric current. These all devices work on. So the bulb, you saw that the bulb becomes warm, so it also works on heating effect of current. Now why does that becomes warm? Why does the geyser, how does the geyser makes the water heated up? How does the toaster works? How does this electric oven works? Any of these devices, how do they heat up? They have a certain thing in them which is called as heating element. It is called as heating element. Heating element are conductors which get heated up. They are conductors which get heated up. All the devices have heating element. Whichever devices work on heating effect, they have special conductors in them which gets heated up when current passes through them, and these things are called as heating element. In geysers, in toasters, in ovens, they are rod. This, you must have seen this thing, very common. It is a water heater. You can see people using this to heat water during the winters. So you can see this coil type, this rod over here, heating rod we call it. This is the heating element. Inside this rod there are wires which get heated up. Same as the coil of wire you see in a bulb. Okay, if you see in a bulb, there's a coil of wire which gets heated up, and that's why the bulb glows. Okay, so all the heating devices have a element in them, heating element, which works on heating effect of current. So you got this thing. These things you can see at your home, your geyser, electric heater, oven, even this hair dryer, it also has a coil inside, it works on heating effect. This electric iron, all these appliances have a heating element in them which works on heating effects of current. You can see, this bulb I was talking about, you can see a coil inside which glows, which becomes red hot. This the filament, we call over here the filament of an electric bulb, it gets heated up and that glows, and that's why you get light over there. When it glows, you get the light when it glows. This bulb filament you must have seen. Okay, but and this bulb also, never try to touch the bulb such, because a lot of heat is produced and it's too hot to touch. Don't even dare to touch it. Okay, so this was about, this all works on heating effect. Now one more thing over here, nowadays you don't see such type of bulbs, very rarely you see these bulbs. Why are not we using this bulb nowadays? Because a lot of energy is wasted due to this heat, and energy we need to preserve. We need to preserve energy, because energy once lost is lost. So here nowadays, in spite of this type of bulb, we are using LEDs bulb, we are using CFL, we are using LED, which gives you the same brightness by consuming less amount of energy, which gives you the same brightness. Okay, so nowadays these bulbs are not being used mostly to conserve electricity. Even our electricity bill comes down by using LEDs. Okay, so this CFL bulb, you must have seen this bulb, CFL bulb. Okay, CFL and LED devices, they reduce the wastage of energy. They give the same brightness but don't give out the same amount of heat. They don't get heated up equally. Okay, so nowadays you can see, so we are replacing those type of bulbs, the filament bulbs which are called as incandescent bulb. We are replacing them with CFL, we are replacing them with LEDs. Nowadays the most favorable thing is LED bulbs, because they reduce the wastage of energy, they reduce our bills also, and we are preserving our energy in that case. Okay, one more thing, these things, whenever we purchase these electric devices, we should use good quality things, good quality products. Okay, our government has given some standard remarks, standard logos to those companies which are producing a good product. Okay, most of them, you can see, you must have seen this mark, ISI, it is given by Bureau of Indian Standards. This mark is given to those products which are good, which are perfect, which are standing by the laws of the government, which are energy eco-friendly, energy preserving, whatever requirements needed. So the government gives this mark to certain products. So whenever you purchase something, some electronic devices, electric bulb or thing, see that they have this mark on that cover pack. Okay, one more thing, due to heating effects, something more happens. What if a large current passes through the wire? Now heating effect is due to current. If a large current passes, if large amount of current passes, large amount of heat is produced, more large. Sometimes this can lead to some mishappenings also. Sometimes it can happen. A large current, how can a large current pass through a conductor, any wire in a house wiring? How is it possible that a large current flows? It can be sometime when the wires mix up, they come in contact. We don't want the wires to be in contact with each other. There are two wires, they should be separate. Somehow they come in contact, we call it a short circuit. You must have heard somewhere in the newspaper or somewhere news, oh, some fire has been caught somewhere, some disaster due to short circuit. What is short circuit? Two wires come in contact. Or sometimes overloading. Overloading is that from the same board I'm using 2-3 devices, one pin this side, one pin TV, then music system, and this 2-3 devices at the same point, 2-3 devices at the same point, that creates overloading. So overloading and this creates more current to flow. If more current passes through a wire, the wire gets heated up more and it can create some mishappening. So what if a large current passes through a wire? The wire may become so hot that it may even melt and break. The wire can melt, such large is the heat. But is it possible for a wire to melt and break? Let's see. wire, when it becomes red hot, it melts and breaks. So you can see over here what's happening over here, and we'll talk about it. Just have a look on this animation and then we will talk about it. This is a wire, circuit on, large current. You can see we are using a group of cells. We are using a battery, group of cells to have more current. So more current is flowing over here. I'm repeating this. The wire becomes red hot and then finally breaks. It melts and breaks. This concept we use. This is again a heating effect of current. We use this concept for our protection also many a times. To prevent some mishappenings, we use this concept, and that is called electric fuse. So electric fuse we use at a home, in certain devices, all devices we use small fuses, big fuses to prevent ourselves from some mishappenings due to heating effect. Okay, how does the electric fuse work? This was the concept. When the wire, certain wire, when it gets heated up, it breaks. So we have electric fuse concept. You must have seen such type of devices on the main circuit board where the electricity supply comes to your home. At the main circuit board there is a device called as electric fuse. This fuse works on heating effect of electric current. Okay, so what happens over here? They have certain wires. You can see if you remove this plug from here, inside it is this way. There is a wire inside. This wire is called fuse wire, special wire which melts easily. The connecting wires do not melt, but this wire melts due to heat easily. So the moment a large current passes through the circuit, this wire melts, breaks the circuit gets off, so no current passes. So we can use it as a preventive measure from high current. So it prevents us. Even different types of fuse. One more fuse over here you can see. This is called cartridge fuse. It is used in many devices. Inside a small tubular structure, glass, there is a thin wire inside. Okay, these two metallic contacts to make the circuit, and there is a thin wire inside. If a high current comes, this wire inside breaks. The circuit gets broken and the flow of current stops. So these devices, the electric fuse, they work on heating effects of current and prevent us from mishappenings due to high current, short circuit. It prevents us from that. So remember, it is the most important thing in our circuit, electric circuit. It is most important thing. So ask your dad, do our house has a fuse or not? If it is not, get it done. Okay, get it installed at your house. So electric fuse, it is a very important point. It is a very important part of a circuit. So if it is not installed at your house, get it installed. Okay, further, so electric fuse works on heating effect of current. Now one thing more, let's come back to it. This fuse gets melted due to heat. Now what to do? Again put a new wire, then plug it. Again sometimes it can get fused, then again use it. So to prevent this again fitting and this thing again, nowadays we have another device, a high-tech device, one more thing called as miniature circuit breaker. This is, in shortcut, we call it as MCB switches, miniature circuit breaker. These are switches, you must have seen this also. Okay, nowadays we are installing this in place of electric fuse. These are automatic, it goes down. The moment a high current flows through the circuit, they goes off. It goes off automatically, no need. So what to do? What was the cause for it going off? Rectify that cause, then switch it on, it will work. No need to again put the wire and again, simply on and off it is. So if there is any problem in the circuit, if the current goes above a certain limit, because we have different switches for different limits. So if the current goes beyond the limit, it automatically shuts down the circuit. Okay, it goes off. So nowadays we are installing this in place of electric fuse. So miniature circuit breaker. So either you should have a fuse or this. Any one of this is a must in a house wiring. Okay, not only house wiring, any commercial, anywhere wiring, any commercial, any place, we need this to prevent short circuit cases. Okay, so these are the devices which works on heating effects of current.